denominator, what's going to cancel there? X is your common factor, numerator. It's kind of hard to cross off an X. Use different colors. Looks like an asterisk. Cross off X, leaving us with X minus 1 times X plus 1. Now this is being subtracted. Careful with your where it's not there. But notice that even though we're still doing some simplifying, there is one thing you don't have to worry about. More fractions and numerators. So being able to recognize the least common multiple, multiply each term by that least common multiple, and then after that, so the rest, as they say, is just algebra. X squared plus X minus X squared. That's going to simplify nicely. Denominator is 2X squared plus 2X. Now here's where we've got to be careful. You're subtracting off the entire product of those two factors, X minus 1 times X plus 1. So go ahead and do X minus 1 times X plus 1 first, and then subtract the entire expression. So what is X minus 1 times X plus 1? It's X squared minus 1. There's no middle term. There's actually the difference of squares. So negative 1x plus x gives you 2x. Okay. So since you're subtracting the entire expression here, it's going to be 2x squared minus x squared, and it's going to be minus negative 1. So what's our numerator going to be equal to? X. Denominator, 2x squared minus x squared gives us x squared. 2x. And then minus negative 1 gives us 1. So the important thing to remember is to get rid of the fractions in the numerator and denominator first. Write it as a single rational expression. Then when you simplify, see when you get down to your final numerator and denominator where all the like terms have been combined, ask yourself, is this now simplified? And the answer is no. Thank you. So I know why you're saying no. Can the numerator be factored any further? No. What about the denominator?
Yes.
It can be factored. What are the two factors?
X plus 1.
X plus 1 times X plus 1. Are any of those factors also common to the numerator? They're not. So I think it's a good idea to write the denominator in factor form. You do not have to do it because in this problem, you do not have to worry about factors. So either one of those two answers will be fine. This one. So I think to be safe, you might as well factor the denominator if you can, because you might be able to cancel a common factor in the numerator. If you leave it like this, you have no chance of even knowing whether you can do it. All right. So questions with the procedure? So you do not have to get a common denominator in the numerator and a common denominator in the denominator. That is another method you could use here that actually produces an answer in a slightly longer fashion than you see here. All right. So here's a nice expression from calculus. Let's call this one from calculus. X plus 1 minus a minus 1 over a divided by x minus a. Call that formula. So we don't need to worry about where the expression came from. It's just when you are encountered with this in calculus, you want to make sure you know how to simplify. Okay, how many terms in the numerator? 4. How many terms in the denominator? 2. We only have 2 examples of fractions in the numerator. We have 1 over x, 1 over a. So everything else in your denominator is going to be 1. So what's going to be our least common multiple of all 6 terms?
Is the one on bottom an A or a 2?
That's an A.
A.
My A sometimes look like 2, so if you have any questions, feel free to ask. That's what we do. So do x and A have any factors in common? No, they're both different factors. So either what's the LCF?
Yeah.
I could help say A and X. Either one. So same procedure. We're going to take each term and multiply it by the LCF. So 1, 2, 3, 4. out the LCF and multiply each term by delta. So x times xa, 1 over x times xa, a times xa, and 1 over a times xa. It's all divided by x times xa minus a times xa. You're going to be saying this over and over again in this class. There are a lot of students in calculus who are pretty good at their calculus, not so good with algebra. Yeah, I can find a derivative. Can't set it equal to 0, but I can't solve the equation, but at least I can find a derivative. We want to be able to do both, so that's why we're working with these expressions right now. So make sure you got the variables straight. This is x squared times a. What do we get here?
Okay. 1 over a.
1 over x times x would be 1 times a.
Oh.
A times x over a, xa squared. And what do I get for the last one? X. You remember in each of these products right here, the denominator will be canceled with a factor in the numerator. So the first one is going to be x, and the second one is going to be a. And then we're dividing by x squared times a minus a squared. That's quite a neat expression right there. Is there anything else we can do with that? Are there any common factors in the numerator to take out of all four terms? Got an x here, 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 but not here. That's not going to work. A is here, 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 but not here. That's not going to work. The denominator we can actually take out is x and an a. I'm not sure that's going to help in terms of simplifying the entire expression.
We can factor it.
You can factor that. Not sure it's going to help in terms of canceling a common factor. Let's give it a try. So the denominator can be factored this way. X and a are both common factors. So we take out x times a. Write down flip over. Notice in the numerator, these two terms have a common factor of a. These two terms have a common factor of x. Maybe we do a factor by grouping there. Let's try it. The denominator is x times a times what?
X.
X. And then x times a times
X squared.
negative a. Now, I'm not sure this is going to work, but in the numerator, let's give this a try. A is your common factor here. Take it out. Negative x is your common factor here. If factor by grouping is going to work, those two factors will be exactly the same. Now, that does not work in every single problem. Let's see if it works in this problem. So a times what gives us x squared times a? X squared. A times what gives us a? What? Negative x times what gives us negative a squared x? A squared. And then here we're going to get oh, you know, we're so close. We have a times x squared plus 1, and then negative x times a squared plus 1. Are those two the same factor?